In this video, we'll explore how advanced laser technology is revolutionizing the aerospace industry, from enhancing precision in manufacturing to ensuring the highest standards of quality and safety. Our eco-friendly solutions are tailored to meet the unique demands of aerospace engineering. We'll delve into unique applications, share innovative uses, and highlight the significant benefits that set our services apart. The unique role of laser technology in aerospace. Laser technology has become indispensable in the aerospace industry, providing unparalleled precision and efficiency in various applications. One of the most groundbreaking uses of lasers in this field is in additive manufacturing, also known as 3D printing. In aerospace, lasers are used to precisely fuse powdered metals and alloys to create complex, high-strength components layer by layer. This technology allows for the production of lightweight parts with intricate geometries that are impossible to achieve with traditional manufacturing methods. Another unique application of laser technology is in the inspection and maintenance of aircraft. Laser ultrasonic testing, LUT, is a non-destructive testing, NDT method that uses lasers to generate ultrasonic waves in materials. This technique is highly effective for detecting cracks, delaminations, and other structural defects in composite materials, which are commonly used in modern aircraft. LUT provides a quick and accurate assessment of the structural integrity of aircraft components without causing any damage. Additionally, laser ablation is used for precise material removal in aerospace applications. This process involves using a laser beam to remove unwanted material from a surface, such as coatings or contaminants. Laser ablation is essential for maintaining the cleanliness and performance of critical components like turbine blades and engine parts. Real-world examples: innovative laser applications in aerospace manufacturing. Let's explore some real-world examples that showcase the innovative use of laser technology in aerospace manufacturing. One notable application is the use of laser additive manufacturing to produce engine components. Aerospace companies are using this technology to create parts with complex internal structures, such as cooling channels in turbine blades. These intricate designs improve the efficiency and performance of the engines, reducing fuel consumption and emissions. Another example is the use of laser ultrasonic testing for the inspection of composite materials in aircraft. Composite materials, such as carbon fiber reinforced polymers, are widely used in the aerospace industry due to their high strength-to-weight ratio. Laser ultrasonic testing provides a non-destructive method to detect internal defects and ensure the structural integrity of these materials. This technique is faster and more accurate than traditional inspection methods, allowing for more frequent and thorough inspections. Lesser-known benefits of laser technology in aerospace. Beyond the well-known advantages, laser technology offers several lesser-known benefits that are particularly relevant to the aerospace industry. One such benefit is the ability to perform high-precision micromachining. Micromachining involves creating extremely small and intricate features on materials, which is essential for producing components used in sensors, microelectromechanical systems, MEMS, and other advanced aerospace systems. The precision of laser micromachining ensures reliable performance and high-quality production. Another lesser-known benefit is the capability of lasers to perform laser shock peening, LSP. LSP is a surface enhancement process that uses laser-induced shock waves to improve the mechanical properties of materials. This technique increases the fatigue strength and resistance to stress corrosion cracking of critical components, such as landing gear and turbine blades. Laser shock peening extends the lifespan of these parts and enhances the overall safety and reliability of aircraft. Stats on efficiency and quality improvement. To illustrate the impact of laser technology, let's examine some relevant statistics from aerospace manufacturing projects. A study conducted on the implementation of laser additive manufacturing revealed a 40% reduction in production time for complex engine components. This improvement was attributed to the high precision and efficiency of laser 3D printing, which reduced the need for assembly and post-processing. In the field of laser ultrasonic testing, aerospace companies reported a 35% increase in the detection accuracy of internal defects in composite materials. The non-destructive nature of laser ultrasonic testing allowed for more frequent inspections, enhancing the safety and reliability of aircraft structures. Energy consumption in aerospace manufacturing has also benefited from laser technology. By replacing traditional methods with laser processes, manufacturers achieved a 25% reduction in energy usage. This decrease not only lowered operational costs, but also supported the industry's sustainability initiatives. Moreover, the precision of laser ablation has enhanced the maintenance and performance of critical components. Manufacturers reported a 20% improvement in the efficiency and lifespan of turbine blades due to precise and thorough cleaning provided by laser ablation. Thank you for watching. If you found this video informative, please give it a thumbs up, share it with your colleagues, and subscribe to our channel for more insights into cutting-edge technologies. We'd love to hear your thoughts and questions in the comments below. Let's stay laser-focused on a sustainable future together.